So we will solve a few problems. Find I of t for t greater than 0 if I of 0 is equal to 5 amperes, right? So here we have a dependent source. Now before I solve the problem, you can pause the video and you can first try it out for yourself. That way it will be a more effective learning, right? Right. So now we see that there is no source here, okay? Dependent source is there, but there is no independent source. So that means this is a source free circuit, okay? And the current, the initial value of the current will drive the circuit, and after a while it is going to decay, right? So then in that case, what will be the value of current through the inductor? This will be equal to the initial value of current into e to the power minus RT by L, or you can write as I naught e to the power minus t by tau in terms of the time constant, right? So what do we need to find? We need to find I naught and tau. I naught, anyways, this is given. How much is it given? 5 amperes. So we need to find out tau. Now how do you find out tau? So we know that tau is equal to L by R. Now L, anyways, there is only one inductor, not an issue. So L is equal to 6 Henry. Now R is the Thevenin's equivalent looking through the terminals of the inductor. Okay. So this is the resistor and you have to look through these terminals. Right, this is 40 ohms. So now whenever there is an dependent source, then how do you find the Thevenin's equivalent? You have to connect a current source or a voltage source. Okay. So this you can slightly redraw so that it will be more clear to you. These terminals, if you are taking as A and B, okay. So now this terminal has become A, this terminal has become B, okay. So you have a resistor in parallel with the current source which is having 0.5 I, and here you have the resistor 10 ohm. This is 40 ohms, okay. So now you are going to connect a current source of 1 ampere. Now the voltage that is appearing across this will be the Thevenin's resistance. Now where is the variable I? I will be the current through the inductor, and this is the through A and B is what is the current flowing, right? So current, you can see it is flowing from the B terminal to the A terminal. So you can write here I, which is 1 ampere because of the current source here, okay. Now at this terminal, if you can see, I is flowing here, 0.5 is going away from here. So what will be the current through 40 ohm? This is going to be 0.5 I, okay. So now you can apply KVL, then you are going to get KVL around this loop, okay. So I will just mark it here. We are applying KVL like this, okay. So here you are going to get V is equal to 0.5 times I into 40 plus I times 10, okay, because through the 10 ohm I current is flowing, and this is equal to 30 I, okay. So now since I is equal to 1, you have 30, okay. So therefore RTH is equal to 30. From here you can find out tau. Tau is equal to L by R, which is 6 divided by 30, which is 0.2. So now what is the expression for current? I of t is equal to the initial value, which is 5, into e to the power minus t by 0.2, or you can write 5 e to the power minus 5t. Next question. Switch has been closed for a long time. It is opened at t is equal to 0. Find current in inductor for t greater than 0. So once again, pause the video and you can first solve it. Then you can see the solution, right? Now before the switch is closed, you can see that there was a source, okay. Source was connected through the inductor, and after the switch is opened, then it will become a only inductor and the resistors. So it is a source free circuit, okay. And now we have to find out the current after t greater than 0. That means after the switch is removed. That means, are we dealing with a step response or a source free response? We are dealing with the source free circuit. Okay. So what are the things that we will be needing to find when it is a source free circuit? We have to find the initial current, that is I of 0, and you have to find the time constant tau. Okay. Because it is a source free circuit. It is source free after the switch position is changed. Okay, so this is the important point, because you might get confused that there is indeed a source here. Okay, so how will you find the initial current? We want I at t is equal to 0 plus, that means just after the switch is closed, which is equal to the current just before the switch is closed, because it is the current through inductor, right? I of t is through the inductor. Okay, so here we will first draw the circuit for t less than 0. Okay, so it has been already given that switch has been closed for a long time. That means steady state has been reached. So we have to draw the circuit in such a way that all the elements are in their steady state conditions. So what will happen to the inductor? The inductor will act like a short circuit at steady state. And once inductor will act like a short circuit, what will happen to the resistances that are connected in parallel to it? Right, this is connected across inductor, this is also connected across inductor, right? So these two resistors will be shorted out, right? So let us now draw the circuit. Here we have voltage source, resistor, 6 ohms, 8 ohms, here also 8 ohms, and this 32 ohm, so we can remove it later. Okay, first we will draw the short circuit. Okay, so since this is a short circuit, we can now remove these two resistors that are connected across the short circuit. Okay, so now what do we have? This is I is equal to t at 0 minus. So what will be the current here? First we can find out the current here, Is, let us say. So what will be Is? This will be 50 divided by 6 plus 8 parallel to 8. Two resistors, two equal resistors in parallel, it will become by 2. So 4. So you're going to get 50 by 10, which is 5 amperes. Then by current division, you can get I of t is equal to 0 minus is equal to, here since both the resistors are parallel, current will be divided equally. So you're going to get Is by 2, which is 2.5 amperes. Okay, so this is the initial value of current. Therefore, I of t 0 plus is equal to I of t 0 minus, this is equal to 2.5 amperes. This is the initial current. Next we have to find out the time constant. Now time constant, how you will find out? You will find out the Thevenin's resistance looking through the inductor terminals. Okay, and the switch is open now, so this part of the circuit will not be present. So what will you get? The circuit here there will be 8 ohm resistor. This is for finding the time constant. Here 8 ohm resistor, here also 8 ohm resistor. Now here we had 32 ohms and here there was 32 ohms, and we have to look through the open circuited terminals of the inductor. This is RTH. Here you can see that there are 3 resistor combinations in parallel. This is one resistor in parallel, this is one resistor in parallel, and this both of these resistors which are in series are parallel to these both. Okay, so here you're going to get RTH is equal to 32 parallel to 32 parallel to 8 plus 8 is 16. Now first 32 parallel to 32, what you will get? 2 resistors in parallel, 2 equal resistors, 32 by 2. So that will be 16 parallel to 16. Once again, both are same. So 16 by 2, you're going to get 8 ohms. Then how will you find the time constant? Tau is equal to L by R TH. Okay. So what is L? L is 2 Henry divided by 8. So you're going to get 1 by 4. Okay. So now what will be the final expression? Therefore, I of t for t greater than 0 is I of t0, that is initial current 2.5 into e to the power minus t by tau. So e to the power minus 4t you will get.